what to do when you have to solve synchronous equation without equal coefficients. Dear viewers, we're going to continue with our synchronous equation, which we started in our last class. And today we are going to look at what to do when for that a particular synchronous equation has no equal coefficient in both equations. 4x plus 6y is equal to 21. 7x minus 3y equals to 3. In x as variable, no equal coefficient. As y as variable, there is also no equal coefficient. Remember, in elimination methods, we need equal coefficient in either x or y to be able to eliminate one to solve the other. Let us see what to do when this is the case. We are going to solve it as 4x plus 6y is equal to 21, and call the first one equation 1, and solve 7x minus 3y is equal to 3 to answer equation 2. Now remember that even though we are solving the values for x and y simultaneously, we must eliminate one first and then solve the other. What does it mean? We need a situation where the same number is here for x, then we eliminate x. Or the same number is here for y, then we eliminate y. Let us eliminate y first. We use the fact that 6 times 3 and 3 times 6 will give us the same number to do that. And so we are going to say, let the equation 1 times 3, why 3? Because of the 3 we have here. No, we don't care about the sign. Because of the 3 we have here. Equation 1 times 3. If equation 1 times 3, we are sure that this 6 will times 3. And equation 2 times 6. If equation 2 times 6, it means that this will times 6. And so we are using that fact to create equal coefficient for y. And so we are going to say in equation 3, equation 1 times 3 and equation 2 times 6. Remember, I've told you we are not going to consider their signs. The only thing we are going to consider is the number we have there. 6 times 3 and 3 times 6. Both of them will give us 18. And that's what we're interested in. Which means equation 1 times 3 will give us 4 times 3 will be 12. 4 times 3 will give us 12x plus 6 times 3 will give us 18y is equal to 21 times 3, which will give us 63. So it is equal to 63, and we call it equation 3. Remember, equation 3 is coming from equation 1. And equation 2 times 6. Let's go to equation 2 times 6, which gives us 7 times 6, which will give us 42x minus 3 times 6, which will give us 18y. And that is equal to 3 times 6, which will give us 18. That will give us equation 4. As of now, we have equation 1 being the same thing with equation 3. We have equation 2 being the same thing with equation 4. So we are going to make use of equations 3 and 4 instead of 1 and 2. Remember, they are the same thing. The only thing we have achieved is that the same coefficient has been found in y. And that will make y easy to be eliminated. Now we have different numbers, different signs. For different signs, add. Because it's when we add two numbers that are the same that we are going to get 0. It's when we add two numbers that have different signs, but they are the same, that we're going to have 0. 18 plus 18 minus 18, 0. Good. So it's addition that we're going to do. We can just do the sign of addition and add two of them. What do we have? We have, adding this will give us 4, adding this will give us 5. We have 54x. Adding 18y plus 18y minus 18y will give you 0. Can you see where the elimination comes in? Because if you don't have to get, we have failed to get equal coefficient, we will never get that y eliminated. Now y has been eliminated by getting it to 0. And we have to get to say equal to, we add this number to give us 1. Yes. 3 plus 8, 11. 1 we carry 1. 7, 8. That means we are getting 81. So now there is no y. We can solve for x by what we have here. Then divide both sides by the coefficient of unknown will give us 54 x over 54 is equal to 81 over 54. In this case, we are going to have 1, x is alone on the left hand side, waiting for the correct answer on the right hand side. And so what do we get? What can actually divide? 9 divide 81 will give us 9. 9 divide 54 will give us 6. Can another thing divide? Yes. 3 divide will give us 3. 3 divide will give us 2. And so we are getting 3 over 2 as answer for x. Remember that 3 over 2 is also the same thing as one whole number, 1 over 2. For what 2 divides 3, we get 1, remember 1. Now 1 is 1 over 2. Okay, now if we wish to eliminate x now, we do the same thing. I think it's better. Let us eliminate x now to solve for y. Alternatively, we can carry 3 over 2, put it in equation 1 and equation 2 in place of y and solve for x. All right. Because we are working with elimination method, and many people will be interested in seeing how this is done here when we have the same sign. Plus 4x plus 7x. Let us eliminate x to solve y. And so we are going to write these equations afresh. That this is 4. This is 4x plus 7. 4x plus 6y is equal to 21. And 7x minus 3y is equal to 3. When we have this as equation 1 as usual, I have this as equation 2. By the time we do this, remember what we want to do is to use complete elimination in both of them. Now we have eliminated y to solve x. We are going to eliminate x now to solve y. To be able to do that, remember we follow the coefficients. Equation 1 times 7 and equation 2 times 4. So we are going to have equation 1 times 7 here and equation 2 times 4. So that we have the same coefficient here. Remember that is the only thing I can eliminate the particular letter we want to eliminate. In this case, x. And so 4x times 7 will give us 28x plus 6 times 7 will give us 20. We give us 42. 42y is equal to, yes, 21 times 7. What are we going to get? 714. will give us 147. 147. And we can call this equation 3. Let this one be equation 3. Now we go ahead to say equation 2 times 4. That means this coefficient should times this to get equal coefficient. And because we want to do it, we multiply everything in order not to create a different question. Okay, so we have to say equation 2 times 4. 28. We have here again 28x, because 7 times 4 is 28. 7 times 4, 28, minus 3 times 4, 12. So we have 12y is equal to 3 times 4, which also gives us 12. And this becomes equation 4. Remember, the same thing we did before, we're doing here. We are going to do something that will remove x, because we've not gotten equal coefficient in x. 28, 28. And that equal coefficient is what we are looking for. If a particular question has already gotten equal coefficient in any of the letters, no problem, you can eliminate. Whereby it has not, we create the equal coefficient as we have just done now, and leave the two equations that gave us the original question and focus attention on similar equation but with equal coefficient. However, you can see that we have the same sign here. The sign of any number is before that number, so it is plus now, plus 28x, plus 28x. And they are positive. When we are having to eliminate y, we have different signs. Here we have the same sign. What do we do? Let us introduce minus here and subtract. In short, this should be something like equation 3 minus equation 4. Everything in equation 3, we take away everything in equation 4 from it. And so 28x minus 28x will give you 0. Can you see how it's eliminated? And that's where the name comes from, elimination method. Then it is gone. We are going to have here 42 minus 12. Remember, it's not going to give you another number from a number bigger than any of them. 42 minus 12 should be plus 12. And that is going to give us 4. That's going to give us 5, 54. So we have 54. That's what we're going to have there. We have 54y plus 54y is equal to, we take away here, 7 minus 2 will give us 5. I hope we are following this. 7 minus 2 will give us 5. And 4 minus 1 will give us 3. In that case, we bring down 1. So our number there becomes 135. 135. By the time we've gotten 135, then we will solve 135. We divide both sides by the coefficient of unknown, which is 54. So we can divide this in our mind and say that y is equal to 135 divided by 54. Divided by 54. finally, we are going to get y is equal to, when we divide here, we get 1. Divide here, we're going to get 2.5. That is 2.5. 2.5 becomes the value of y. Therefore, from this calculation, using the elimination method, x is equal to 1 whole number, 1/2, and y is equal to 2. Okay, remember that if you substitute the value of x here, which is 3/2, and substitute the value of y, which is 5/2, you are going to get 21 on the left hand side, which is actually waiting for us on the right hand side. We have solved this question now using elimination method. I hope that is understood very well. Okay, now we are going to continue with other number here. This number is a little bit different from the other one. The topic is still remain synchronous equation using elimination method. Let us see how elimination method can continue to solve for us, especially when we get to this number 2. This is our number 2 today, and this is number 3. Number 2. In number 2, we can see that the number we have are not well arranged, and the letter we have is not well arranged. Therefore, the first thing we're going to do is to arrange the letters. Let us arrange the letters the way they should come. We already know that we have A before B in the alphabet, and so we are going to position A first. And remember, the general position of synchronous equation will always be 2 letters on the left and the number with that letter on the right. And so we are going to maintain that in question number 2. The first thing we're going to do then is to arrange the question to be 4A, 3B will come to this side, we have plus 3B, then is equal to 1. Remember, the one we have here is already on the right hand side, and it does not affect here by the negative sign. Good. And now the number 2 is going to be, question number 2 is going to be, bring 6A here, 6A plus 4B, that is equal to -1. Where we call the first one equation 1, we call the second one equation 2. Yes, I now know that we're also going to use the elimination method to work them here, just as we did before. Can we do that? All right, let us use the elimination method and eliminate B first. If I go to eliminate B, what are we going to get? What do we do to eliminate B? We must create equal coefficient in B. If I'm going to eliminate A, we must create equal coefficient in A. And because we have decided to eliminate B, we are going to say we need U to times 3. Yes, we need U to times 4. Because 3 times 4 and 4 times 3 will give us 12 each. And because we don't want to create a new question, everything in equation 1 will times 4, and everything in equation 2 will times 3. Therefore, we will give it the same rule as equations 1 times 4 and 2 times 3. We have given ourselves a rule, and we have to follow that rule strictly. That means equation 1 times 4 will give us 4 times 4, 16A, plus 3B times 4, 12B, is equal to 1 times 4, will give us 4. We call that one equation 3, which is coming out of equation 1. And so we do the same thing, equation 2 times 3. You are in equation 2, and so 6A times 3 will give us 18a plus times 3 will give us 12b times 3 will give us minus 3 is equal to, this one will become equation 4. You can see that what we are looking for has come. The equal coefficient we are searching for has come in B because of what I've done. And they have the same sign, positive sign in each case. Remember, when you have negative sign in the same case, or positive sign in the same case, subtract. When you have different signs, add. Eliminate the one with equal coefficient. And so we are going to do that immediately. All right, let us do the subtraction. If we like, we say equation 3 minus equation 4, or equation 4 minus equation 3, whichever one we say, we'll follow it strictly. Then, let us do it the way we have done it before, and take away equation 4 from equation 3. When we do that, we're going to have minus, 16a minus 18a will give us minus 2a. 12b minus 12b will give us 0, and so it has been eliminated. Then 4 minus minus 3 will give us plus 7. I hope you understand that. That's 4 minus minus 3 will give us plus 7. And so we are going to divide both sides by the coefficient of unknown now, which is minus 2. We're going to get a is equal to minus 7 over 2. Don't forget that minus 7 over 2 is going to give us a is equal to minus 3.5. Now we are going to substitute. Let us substitute the value of a. Anywhere we see a in equation 1 or 2, we put minus 7 over 2. Let us do that immediately. When we do that, we are going to have replace or substitute minus 7 over 2 in equation 1. Yes, anywhere you see a, you put minus 7 over 2. And so we are going to have it as a into minus 7 over 2 bracket plus 3b is equal to 1. We are doing this to be able to solve b instead of eliminating b to solve a, instead of eliminating a to solve b. No, yes, so we are going to make sure that we substitute now. When we have used elimination to solve one, we can now substitute and get the other. All right, what do? We have here 4 times minus 7 over 2, and 4 is 4 over 1. This is together plus 3b is equal to 1. And so we have here 1, we have here 2. Minus 14. Okay? Minus 14 plus 3b is equal to 1. Okay? Is it possible for us to take this number that has no letter to the other side? Yes, it is. So that is collection of like terms. And so we are going to have here 3b is equal to 1 plus 14 will give you 15. And so b is equal to 15 over 3, which gives us 5. Therefore, we are concluding that a is equal to minus 3.5, while b is equal to 5. That's correct answers. Dear viewers, you can see actually that we can use the elimination method to solve synchronous equations. And the major thing we want there is equal coefficient of one of the letters. Whereby the two letters have equal coefficients, then we can choose what to do. That time it will be very easy. It will be easier than what we should do. In our next class, we are going to solve synchronous equations with unknown in denominator. That is that number 3 there. And please, as we always want our students, our learners to work ahead of us, we are encouraging you to try this for that class. Hopefully, our class will continue to be on every Sunday at the same time. Thank you very much. See you in the next class.